Okay, guys. So, welcome this evening to the AI Club meeting, and thanks for joining on a festival day. So, this shows your like how you are how eager you are actually. So, let's start. So now sampling. Like yesterday, I think we completed a lot of basic terminology for statistics. So I'll not get into that because yesterday we discussed in quite in depth. So I'm not repeating that. So let us quickly glance through sampling and sampling methods which are available. So like sampling method, like what is sampling? Everyone knows why we do sampling. The population is like examining entire population is very large. So we take a sizable like representative sample, analyze it, and based on our conclusion on sample, we infer about the population. That's what we do in statistics, right? So like sampling methods. So what is the importance of sampling methods? So importance of sampling method means I told you like sometime back yesterday only that taking the right sample, like see if population is having suppose Sikkim population we were talking about yesterday, so 8 lakh people. So for to do any statistical study, what kind of how many people I should take in my sample? 2,000, 2,500, 3,000, 10,000, so that it properly represents the population of Sikkim. So determining that number also is a math problem. It's a statistical problem. So that is the importance of sampling methods. With using some sampling methods, we can decide how much should be the sample size. Okay. Then, we and definitely to save time, effort, and money, definitely we want to work with the smallest sample we can work. Like if population is huge, so we will like whatever is the smallest sample justified with maths and whatever smallest sample justifies mathematically. That's what we want to take and do experiments on that or whatever interview, anything you want to take, you do that. And then based on that, you can do your inferences on the population. So generally, see, there are so many sampling methods here. One style is probabilistic sampling methods. And right hand side, the green boxes you can see. And the right ones are non-probabilistic sampling method. Yeah. So you're not lost much. So we just discuss sampling methods and why we need sample. What is our aim at the time of taking sample? So at the end of when we take the sample, our aim is to take the smallest sample. Why we want to work with smaller sample? Because it is easier, it is cheaper, it is less time consuming. And based on that, working on that small sample, we infer about the population. So two main type of sampling methods are there generally. One is probabilistic sampling methods, and right hand side the blue circles you can see as non-probabilistic sampling methods. So you can see some of the names like simple random sampling, cluster sampling, like systematic sampling, stratified sampling, stratified random sampling, and convenience sampling. Then right hand side I'm reading now the blue ones, judgmental. Then you have snowball sampling, quota sampling. So you can see there are so many ways of sampling. We are not getting into details of these sampling methods, but like in statistics in general, randomness is very important. Like suppose you are suppose you are not manufacturing some nuts. You are manufacturing nuts in a factory in large number. So suppose nut lot is 300,000 nuts. In one lot, there are 300,000 nuts. And suppose in sampling methods decides that out of these 300,000 nuts, we take mathematically it will be right if we take a sample of 300 nuts, and then we'll do some quality study on that. We'll take their measurements and see whether measurements are within desired limits or not. Those things we'll see. And suppose my within the sample I find that 99% of the nuts are within the tolerable limits, then I will pass the sample. If only 90%, if my measurement is says only 90% of 90% of nuts are passing my tolerance criteria. Less nuts are like either short or long. So those kind of things, then I will reject the whole lot. That I will do that, right? So when we take a sample of 300 nuts, say 300 nuts are when I take the sample. So it is very important that I pick up those 300 parts randomly. So like suppose there is a big heap of nuts, 300,000 nuts. So one nut, like there should be some method to take randomly, like one from here, one from there, one from there, one from there, one from there. So like that, I should take some very randomly. I should pick up. Like I should never ask the guy, like the worker, to take the sample, because worker knows lot one was kept this side, lot two was kept this side, lot three was kept this side. Worker has some bias, so he may tend to choose sample only from one of the lots. That kind of sample will be biased.
Sorry, sir. Sir, Gajendra and Anup are waiting in the lobby actually.
Okay. So okay, so like suppose in 300,000 each, suppose each thousand 300,000 total nuts are there, and suppose each lot I am producing 10,000 nuts. So there are 30 such lots. 30 such nuts were 300,000 nuts were manufactured in 30 lots. So 300 sample, when I take a sample of 300 nuts, they should be collected from all the lots, not from a single lot or two lot or three lot. All the 30 lot I should collect some from lot one, some from two, some from three. Like that randomly I should pick up my randomly I should pick up my sample. Then only it will be my statistical results will be right, because randomness carries a lot of weightage in all statistical measurements, all statistical experiments. Randomness carries a lot of weightage. Suppose you take nuts only from one lot, and all they are okay, but other lots were not good. Based on one lot, you said my nuts are within the limit, like my measurements are within the limit, and you pass the whole lot of 300,000. But the nuts were belonging to only single lot. So your results are biased. Okay, so to avoid that biasness, you should randomly select from the entire lot, and the 300 or whatever 300 sample I am taking for quality control, they should be selected from entire from entire lot. It should be selected. That is number one. Now there are couple of things like suppose your statistical sample is a mix of three parts. So part number one is 60%, part number two is 20%, part number three is 20%. So total 100%. Part one 60%, part two 20%, part three 20%. So total 100% you have kept in a like one method to take the sample is randomly I pick up, like I don't see which kind of part I'm picking up, but I randomly blindly pick up some random parts and do quality control. So in that in my sample, the proportion may not be 60-20-20. Lot, it is proportion is 60-20-20. But when I randomly pick up, I may not have the part one 60%, part two 20%, part two 20%. Like that, I may not have in my sample. So that is one sampling method. So one sampling method is stratified. So stratified sampling method means like I deliberately take in my sample, like whatever sample I am going to study for my measurements, my statistical study. So 60% I'll take up from randomly I'll pick up from lot one, 20% I'll pick up from lot two, and 20% I'll pick up my sample also from lot three. So the complete heap, the complete population is having part one 60, part two 20, part three 20, 60-20-20 ratio. So if I pick up proportionately like 60% for part one, 20% sample from part two, 20% sample from part three. Like that, if I pick up, my sample will also maintain the same ratio. 60% part A, 60-20-20 ratio will be in sample. So my ratio, the ratio of three parts, part one, part two, part three, in my population as well as in my sample, both are equal. So that kind of sampling is called stratified sampling. So both kind of samplings are possible. So I just gave you two examples like simple random sampling and stratified random sampling. In the simple random sampling, you just randomly pick up. You don't care about ratio. But in stratified, if suppose in original population, the ratio is 60-20-20 or three parts, 60-20-20. So you ensure that sample also has the same ratio. So that is called stratified sampling. So we are not going beyond details. I'm just giving you two examples. Other than that, you can see that I have listed here 10 methods I have listed here. Okay. So like if I go through all the details, then it will take more than an hour or two. So I'm not taking you to, and that plus that is not required for data science also. In data science, we are assuming that data is available to us, and if not available to us, some data engineer will be available to give the data to us. It's not a small company. In bigger companies, data engineer will always be available. Who will like arrange the data and who will then data will be provided to you in bigger companies. But if you are company working in smaller companies, data collection job also has to be done by data scientist only. Depends on the situation. Okay. So here 10 methods are given and two I have explained. Which one I have explained? Random sampling. Random sampling and then stratified. So you understand, right? So in random sampling, I don't care about the ratio. What is the ratio in population and what is the ratio in sample? I don't care. I pick up some. And in stratified sampling, if suppose original ratio was 60-20-20, part one, part two, part three, 60-20-20, I ensure that in sample also, in the same ratio, I have the sample also. That is called stratified sampling. Okay. So the same thing in a different kind of diagram I'm giving you. So like it is one way of representing, it is another way of. So two mainly is probabilistic and non-probabilistic. Okay, now on sampling, like if you are interested more, I'm giving you one article with this PPT. I'll share you in the same group after this meeting. I'll share this PPT today, so you can read this particular article from LinkedIn. It's a very nice article on type of sampling. So all the samplings, they will explain you what are the sampling methods, and they have explained with examples, with real life examples. They have explained with real life examples. Okay. So beyond that, we are not going into sampling method. Just you have to, for this lecture was to remind you that there are so many kind of sampling methods, and couple of them I explained you. Okay. So like that, you can go through this, and then you can make yourself aware about more about sampling methods from this article. Okay. So that's all about sampling methods. Then, like any curious mind will tell, but sir, you showed us around 10 sampling methods. So why you need so many kind of sampling methods? Why you need so many sampling method? Why not only one kind or two kind? You showed us 10. So why there are 10 kind of sampling methods? There can be more kind of sampling. I'm showing you just 10. So why so many? So then we have answer here. So the answer is in front of you. Try to read with me. Finally, the best sampling method is always the one that could best answer our research question while also allowing the others to make use of our results. Okay. When we cannot afford a random sampling method, we can always choose from non-random sampling methods. Okay. So here, like you should be like, if you are a data collector, if you are working in market research or those kind of fields, so you have experience of collecting data. Okay. So data collection method and what sampling method you are taking. Data collection is nothing but sampling method, right? So data collection and collection of sample, which method to choose? So you have to, as per your research question, as per your problem, as per your business problem, you have to choose your like method. So I'm not going into much detail. In this situation, you have to choose which sampling method. So like this article will answer all those questions. But random sampling is generally like if you want to make a sample truly random, statistically, mathematically random, truly random. So such kind of random sampling usually is costly. Generally, it is costly. So like I'm telling you, see, take the same example of yesterday. We want to find Amitabh Bachchan's popularity in our northeast state of Sikkim. And now, Sikkim population is 8 lakhs. It's a fair estimate. 8 lakhs is a fair estimate. Now you go to Sikkim and 8 lakh people, you cannot work with 8 lakh people, right? Spread across the state in jungles and mountains and here and there. You cannot work with all of them. So you will take a sample. So now you want a representative sample, right? You want a representative sample. So like what most media people will do, people will go to Sikkim. They will land in Gangtok and some tourists here and there on this mall, that mall, or that road, the mall road, or some major tourist spots. They will go and they will interview some 200-300 people, and based on the results, they will say, well, yes, these all people know a lot about Amitabh Bachchan, so we can say that Amitabh Bachchan is popular in the state of Sikkim. So now tell me, if I go as a media person and I go in only in Gangtok, which is urban area, big urban area, and I interview some random tourist. Is it a representative population of Sikkim? Is it a representative population of Sikkim? Gangtok in an urban area I go and I interview some random people, some random tourists here and there. So will it represent true population of Sikkim? That is my
No,
question,
sir.
guys.
No, sir.
It will not, right?
No.
Because like Sikkim is mainly your place, which is mainly stays scattered in villages, small villages. Urban area people usual awareness awareness of people awareness the people like awareness is usually more in urban areas. So if you random people if you interview random people in Gangtok and say Amitabh Bachchan is popular in Sikkim, it will not be a right kind of representative population. Okay, so what you have to do? If you want a true sample, true random sample, you should go to East Sikkim, you should go to West Sikkim, you should go to mid of Sikkim, you should go to urban Sikkim, you should go to small villages, north of Sikkim, remote villages, some small chunks you have to enter. Then only you can say that you have got the true representative sample. But is it not costly to go in remote villages, travel all over the places and talk to so many people? Is it not costly, guys?
It will be costly, sir.
It will be costly. So most media news which you see, or the media search articles you see based on polls and all, what they do? Simple people, they will like based on some here and there, they will interview some 200 people, and they don't care about sample size also. If they have 1 hour, they will interview 30 people, and if they have 1 day, they will people 300 people. They won't care about sample size. What is mathematical sample size? They generally they don't care. That's why the results are results of these surveys and all are very unreliable. So they never take a true random sample. They never take a true random sample. So generally, whenever you take a true random sample, then results can be reliable. They can represent they can truly represent the population. But if you take a random sample, if you want to take a truly random sample, it is usually costly. So in such case, there are some reasonable methods or some reasonable right-hand side blue circles you see. So there are non-probabilistic methods which are little less costly than probabilistic methods are little costlier to collect the data. So these non-probabilistic methods are little less costly. You can go for them. Okay. So this is all about now sampling method. So why we do sampling? Why do we sampling? Like we have already discussed it saves time, saves money, and you can collect richer data. So like whatever data you collect, if it is truly representative of population, if it is truly random, then it is very rich data, like very small sample but rich kind of data. So you can do your studies nicely instead. If you study 8 lakh people in a stretch, your study may not be that accurate, or you may have a little bit slackness, or your sincerity may not be maintained for so many days. But if you are working on a smaller group, 300, 400 people, you can do a better job. Okay. So that kind of examples are that kind of advantages are there with. Now we come to our true interest of topic, which is the type of statistics. So there are three type of statistics written in front of you. Do you have idea of any one of these types? Can you tell me about it? Anyone about anything? Any one of three? Three are given in front of you, right? Anyone knows anything about anything, all the three? Anyone, two, anything? Okay, don't worry, over the one. So there are three these main type of study. Will say descriptive, inferential, and prescriptive. So I'm not taking you to this definition. This is the formal definition which you can go through later. So we'll directly go to jump to like our example. Examples. Then I want you to understand through practical examples rather than going through this theory and I explain this theory. So that won't make much sense. We'll discuss examples. Okay. So now descriptive statistics. Descriptive statistics. Like I want you to remember these three circles. Descriptive statistics means what happened in the past, whatever data I collected, what is the mean of the data, what is the standard deviation of the data, what is maximum, what is in that data, what is the maximum, what is minimum, what is midpoint, what is median, what is mode, those kind of things if I see. So I'm analyzing my past data. So when I'm analyzing my past historic data, I'm interested in what happened. When I'm analyzing old data, previous data previous to today, like yesterday and before data, if I analyze, what I'm doing what happened in the past. That's what I'm doing. So that is something called descriptive statistics. Now next comes predictive statistics, like based on like whatever history I have seen, historical data I have seen. Based on that, can I predict future? Next 3 months, next 6 months. Like I'm analyzing, suppose business outcome. So suppose I'm analyzing business of a restaurant. So everyday data of 3 years data restaurant will give me every day how much. This is what revenue, my revenue for 365 into past 3 years. Past 3 years, 365 into 3. This much data I'm giving you every day this much was my revenue. Past 3 years data he has given every day's revenue. Past 3 years. That data was he will give you, owner will give you. Now he will ask you, you are a statistician, I will pay you for that, and you predict me that next three months, what my revenue will look like. Every day, daily basis, what will be my revenue graph? Up, down, up, down. So suppose it is Christmas and some holidays, Saturday, Sunday, it will go up. Some weekdays or mid like afternoons, it will go down. This kind of data you can do, right? So based on historic data, you can give him a prediction of next 3 months. Boss, as a restaurant owner, this is your income going to look like for next 3 months. So now you will count your like you will take time of the day, you will take place, you will take holiday, you will take a weekday, you will take a festival, you will take a shopping festival, you will take any tourist festival, all things you will take into account and tell him for next 3 months or every day, this is going to be your income graph. First day this, second day this, next 90 days you will give him. From next tomorrow till next 90 days, you will give him prediction. This is possible with regression, right? Telling you right itself, it is possible to do. Like if past data is given to you, this kind of prediction you can do with the help of some regression analysis. Okay. So that is your predictive analysis. Now, predictive analysis is simply based on some past data and predicting the future. Nothing I have done. Happy. Restaurant owner is happy. But now, if you are a very seasoned kind of data scientist, you can tell him that past data was like that. If you don't do any changes in your food menu, food menu and your restaurant timing, if you don't change anything, this is your revenue going to look like from tomorrow to next 90 days. But I am as a data scientist, I'm giving you some suggestion. If you implement those suggestions, it is likely that your income every day will increase by 20%. Maybe you add some new dishes, some new dish you add up. Like if it is a Chinese New Year, then a lot of Chinese people will come to Singapore. So Singapore's restaurant should stock more stuff which Chinese people like. Okay, so it is Hindu Deepavali is coming. Then a lot of Hindu guys will come. Tamilians will. There are a lot of Tamilians in Singapore, right? So they will go in a lot in to do marketing. So they should keep some item which Tamilians like or Indian people like. Okay, so this kind of suggestion you can give based on historic data. So you will ask restaurant owner to like day one, day like for next 15 days you keep this menu, then from next week you keep this menu. Those kind of menu changes you will give him. This is for next 90 days. Every 15 days you should have this kind of menu in your restaurant, and you have to advertise it. Okay, once he does, then maybe that is then maybe that is he will see some improvement in his revenue. And if you are a data scientist, and if not change it, like suppose his revenue is like his menu is fixed, you can tell him that in this local paper you advertise, in this place you will advertise. Those kind of advertising you can suggest, some kind of marketing advertising activity you can prescribe him so that he can increase his money. So it is like a doctor. You are like doctor will tell you a lot of ways to improve your health, right? Doctor will tell you a lot of ways to improve your health. Similarly, as a business doctor, as a data scientist, you are a business doctor. So as a business doctor, you will tell some prescription that you advertise in this paper or you make these changes in your menu to increase your revenue. That kind of statistics is also available. That is called prescriptive statistics. Prescriptive means whatever doctor write prescription, no. Same thing. Doctor write prescription about your health. Then you are as a business scientist, as a business analyst, you will write the prescription to improve the business revenue. Same. Doctor is doing for health and you are doing for business health. Okay. So these three kind of statistics I want you to remember. Apart from that, this is a level of difficulty. It's a level of difficulty. Like graph is very simple. See the graph. If you see, I will make this diagrams down. See the graph now. Like when I analyze old data, historic data, what happened? Descriptive analysis, mean, median, standard deviation, maximum, minimum, quartiles. When I deal with these kind of things, that is descriptive analytics. That is simplest thing because data is available to me. I take some statistical tool, analyze something, and present him something. Done. Very simple. Then what? Then there is another question comes. Whatever happened? Why did it happen? Why did it went like that? Like suppose doctor is analyzing your health, and suppose you are sick for the past 2 months. Doctor will come to your house, and you cannot go to. Suppose somebody cannot go to hospital. Doctor comes to house, and you will tell him, sir, his past 2 months is bedridden. And when doctor examines him, doctor has to tell now why he is sick for the past 2 months. Doctor has to tell you. Otherwise, you will not believe that doctor. Doctor has to tell you why this particular guy is sick for past 2 months and what has happened to him. So what has happened in the past 2 months? Why did it happen? Why did it happen? What was the reason behind it? Why this guy is sick for the past 2 months? This kind of reasoning he has to give. So that is diagnostic analysis. Then doctor will do. Now doctor will like suppose it is a very severe cancer, third grade cancer, third level cancer. Then many doctor will tell not you, God's sake, nobody should get it. But suppose any XYZ person is in the third level of his cancer. Then some doctor like will see X-ray and all those kind of things, and reports are hopeless. So they will tell boss, this guy doesn't have life more than 6 years, 6 months. And today, this guy doesn't have life more than 6 months. So whatever he has to do, like he has to write his will or whatever he has to do, he has to do within 6 months. Beyond that, but people with more willpower generally will see that They generally deny this kind of doctor. Doctor will say that he can live only for 6 months, but if your willpower is good and you are a true believer in God, generally these people will survive for much more longer. It happens. Okay, but let us come to business. Now, seeing the historic data, now business, we are telling to the business that predictive analytics I have already explained you through the restaurant example. And that prescriptive analysis also we have discussed. So level of difficulty. So level of difficulty, descriptive analysis and diagnosis analysis is kind of medium difficulty. Then predictive analytics is a little bit more difficult than descriptive analytics. And prescriptive analysis, the doctor prescription. So prescriptive analysis is very difficult to do. This kind of, so there are difficulty levels of statistics. Simplest one is your first circle. What happened? Then what will happen is middle difficulty. What will happen? And what can we make? How can we make it happen? Like how can we improve the business? How can we improve the revenue of business? So those kind of things are generally called prescriptive. So they are most difficult things to do. Okay. So now as a data scientist, when you will start, so you will start with descriptive analysis, descriptive analytics. You will start. So you will make some charts and all that. You will see what is there in my data. What is the pattern in my data? So that is nothing but your descriptive analysis. You will do some data analysis with the help of charts and figures, charts and plots and those kind of things you will do. That is called exploratory data analysis. So that is nothing but your descriptive analysis. That's where you will start. After that, once you do all these things, then you will apply statistical model. Why you will apply statistical model? To predict in future what is the how my revenue is going to look like for next 90 days. These kind of questions we will ask. Maybe regression analysis, logistic regression, or if problem is very complex, then you can go for neural networks. Those kind of things you will apply and then predict the future. Okay, so that is predictive analysis. That is next level. And then prescriptive analysis. What changes you should do in your business so that your revenue improves. You will be a doctor, you will be write a prescription like a doctor for his business. So that is the third level. That is the most difficult thing. Okay. So next, now let us come
Sir,
one by one. Yeah, guys, any questions here?
yeah, so what's the value denotes in the y-axis in the previous graph?
Where?
Previous diagram, the value on the
Y-axis is
y-axis.
your difficulty. Like y-axis is
So x-axis is
y-axis.
difficulty, right? Yeah.
X-axis is increasing difficulty.
And what is
Like
y?
value, yeah, value you bring to the business. Yeah, value means value you bring to the business.
Okay.
So like descriptive analytics, little value. If you do predictive analytics, that is more value to the business. And most value you are bringing when you are giving him prescription. You should do these kind of changes in your business so that your revenue improves. So value is more. So value to the business is there on the y-axis.
Okay. Thanks.
And to get the full value, you have to do all the three statistics. Get the full value, full potential of like to realize the full potential, you have to do descriptive, you have to do predictive, and you have to do prescriptive. All the three levels you have to do to realize the full value. Okay. So any more questions, guys, here? Guys, any more questions? Guys.
No, sir.
Oh, sorry. So we go ahead now with one by one. We are going into different kind of statistics. So descriptive statistics. So descriptive, I have already told you. You have data, and you want to see what is there in that data. And whenever I have data till from yesterday and beyond 3 years, beyond 4 years, beyond 5 years, yesterday, last 5 years data. So what is there in there? I should understand now what is there in my data. So when I answer those questions, that is descriptive statistics. So what are our parameters? So parameters are your nothing but your mean, median, mode, then quartile, then you have quartile, then you have range, minimum, maximum, then you have standard deviation, variance. These things to describe about data. Mean, median, mode, quartile, minimum, maximum, standard deviation, and variance. So these kind of things when you talk about, you are talking about descriptive statistics. So let us see, like, if you don't understand, we'll come to this one by one. So like, I want you to first understand mean, median and mode, first of all. So when you talk about so mean, median, mode are called central tendency. These three measures, mean, median and mode, they are called central tendencies. And variability means range of data. So range of data measure is measured by standard deviation, variance, minimum value, maximum value, and there are two more which are very new to you, which is kurtosis and skewness. So all this will cover one by one. So now today I want you to cover, I want you to know about mean, median and mode. In one class we have discussed it in very detail. So I want one of you to tell me what is mean, what is median and what is mode. Anyone, guys? We have discussed in great detail. In
Yes.
one class, half the class I had devoted to mean, median, mode. So I want you to give the answer now. What is mean, median and mode?
Mean is the central value of the total number.
What is central value?
Let's say whatever is the total divided by 2.
Number of the total number. Yes. Got it. Average. Simple average.
Simple average, yeah.
What is median? Suppose I am giving you 5 numbers. 1,
Yeah.
2, 3. Suppose I am giving you only the 5 numbers. I am giving the value also 10, 20, 30, 40, 50. 5 numbers are there. 10,
30.
20, 30, 40, 50. Only these 5 values are there in data column.
Yes.
There is a data column in which only 5 entries are there. 10, 20, 30, 40 and 50. What is the value of median?
30.
30, right? So middle value is median. Now I am giving you same data column but 4 values. 10, 20, 30 and 40. Now what is median? Only 4 are there. 10, 20. Previously I gave you 5. Now I removed the bottom one.
Yes.
Now there are only 4. 10, 20, 30 and 40. So 40 are there. Now tell me which one is the median. There is no middle value in that.
Sir, average of this, median is like
it's a range between 20 and 30.
You are very near to it, but you are forgetting, guys. Amit, you are correct. It is average of 20 and 30.
Yes, sir.
So middle two values you will take average. If number is even, then you will take average to middle value. If number is odd, middle value. Okay. Now tell me, I'm giving you one number. You listen, I'm giving you 6 numbers. 10, 10, 20, 20, 20. 10, 10, 10, 10 2 times. 20, 20, 20 3 times. And then 3 and then 30, 30. What is the value of mode?
20. Sorry, the mode is like
10, 10.
Yeah.
One is 10, second is also 10, third is 20, fourth is 20, fifth is also 20. Sixth is 30, seventh is 30. Like that. What is the value of mode?
Sir, all will be, considered at. Okay, you are asking me the value of mode.
Value of mode. Tell me, I am giving you 7 numbers I have given you.
Yes, sir.
What is the value of mode, guys? See, mode means the most repeating value. You count the frequency.
Yes.
10
so
is there how many times?
2 times. 20 will be
20 is there how many times?
3 times.
And 30 is there how many times?
2 times.
2 times. So whatever the count you have taken, that is called frequency.
Yes.
Which frequency is the largest?
20.
20 is 3 times, right? So what is the value of mode?
20.
What is the value of median in this case? 10, 20, 10, 10, 20, 20, 20, 30, 30. What is the value of median?
20.
20, right? So you got it now. You understand the difference between mean, median and mode. Okay.
Yes.
So now one by one, now then that day I showed you one example also from web, how to calculate standard deviation and variance. Want me to take it up again? Standard deviation, variance, I told you how to calculate.
Yes, sir. That from the table, you.
From the table I told you, na?
Yes, sir.
So guys, we'll finish with standard deviation and variance today. So minimum and maximum you understand, right? So suppose 10, 20, 30, 40, 50. I give you 5 values. 10, 20, 30, 40, 50. What is minimum? What is maximum?
10 and 50. 10 is the minimum, 50 is the maximum.
Right? You got it.
Right,
Very,
sir.
very everybody understand. Now, how to calculate standard deviation? So for that,
Difference of value from the mean.
it is something like that, but how to calculate it? Wait a minute. Give me a minute. I will search something and then I will. I'm trying to search from the web where I got numerical examples. Okay. I think last time also. Okay, let me check. Okay. So now I share my screen again. Okay. So you can see my screen, guys, right? So I got here an example from Statistics Canada. So there is a small, nice example given here. You can see my screen, guys, right?
Yes, sir, it is visible.
Yes, sir.
So now there is a this whatever is shaded box is there inside. Well, you can see one shaded box, right? Calculation of variance and standard deviation, example 1. So we are going through that right now. So our data set is having 5 numbers: 2, 7, 3, 12, and 9. 2, 7, 3, 12, and 9. Only these numbers, 5 numbers. Okay. Now you have to calculate standard deviation and you have to calculate variance. Okay. Or only this set: 2, 5, 3, 20. Only 5 data is given. But in computer, you can put 50,000, 20,000, it will calculate the standard deviation in 1 minute, half a minute, or even 5 seconds. But here we are doing hand calculations, so we have taken only 5. 2, 7, 3, 7, 12, and 9. So what first we have done? We have done the total. That total, if you count, 7 plus 2, 7 plus 3, 10, plus 2, 12, 12 and 9, 21, 21 and 12, 33. So sum total is 33. Number are 5. So if I do 33 divided by 5, my average is 6.6. Got it, guys? Till here you got it, guys?
Yes, sir. Clear.
6.6, right? Now you do one thing. Take 6.6. You subtract from all these 5 numbers: 2, 7, 3, 12, and 9. So 2 minus 6.3, here it is given. See first value. 2 minus 6.6. First he has done and done the square. Have you seen here, guys?
Yes.
Huh?
Yes,
now,
sir.
this first he has done, so I get square as 21.16.
16.
So I put it here. Now I do 7 minus 6.6. How will I get? 7 minus 6.6. How much I will get? 7 minus 6.6. 0.44? 0.40? 7
Yes.
minus 6.6. 0.40, right?
Yeah.
So 0.40, if I square, what will be there? 0.16, right?
16. Yes.
And now 3 minus 3.3, if I do 3 minus 6.6, I'll get 3.6, right? 3.6 square, if I do, I will get 12.96. Then 12 minus 6.6. So I'll get 5.6, right? 5.6 I'll get. 5.6 square, if I do, I will get 29.16. Then last, 9 minus 6.6. 9 minus 6.6, if I do, I'll get 5.76. If I do 9 minus 7.6, how 9 minus 6.6, guys, how much I'll get? 9 minus 6.6.
2.3. Sorry, 2.4.
2.4.
2.4. Yeah.
If I do 2.4 square, it will be 5.76. So if I add up all the, see what I have done? First I have found out the average. Average is very easy to find average. Everyone knows. So I found out average. Then I did one by one, all the 5 terms I took. Take a difference with took a difference with average and did the square. That's what I did. Simple. Added up all the 5 numbers, square number. So this is my variance. So how much is my variance, guys, here in front of you?
69.20.
69.02. 69.2.
69? No, this is not variance. So this is the square, sum of square. Then you have to calculate variance. Then you have to find, you have to divide by the total number. 69.20 divided by 5. So how many numbers I had? 2, 7, 3, 12, and 9. So 5 numbers I had. So this 69.20, whatever I got, I have to divide by total number. So 5 I have to divide by 5. I am getting 13.84. So now how much is my variance, guys?
13.84.
13.8. Now how will I calculate standard deviation? I told you that day. How
Yeah,
to calculate
square
standard
root
deviation? Huh?
Square root of 13.84.
Yeah, so if you take the square root of 13.84, it will be 3.72. Got it, guys? How to calculate standard deviation and variance? Very
Yes, sir.
simple it is. Okay. So now, what does it represent? Standard deviation and variance. Actually, both are same. Standard deviation and variance both are same. But what does they represent? What I am doing here, I am taking the average, and then I am subtracting the average from every number. So I am taking distance from average, right? When I subtract from one number, it's like 2 minus 6.6, 7 minus 6.6. And I'm taking square. So I'm taking the distance of that point from that particular average. Average is 6.6. So I'm calculating the distance of every point from average. Got it, guys? When I do square, when I take a difference and I do square, I'm calculating the difference of that point from that average, average point. Got it, guys? Yes or no?
Yes, sir.
Yes, sir.
Okay, so when I'm calculating the distance, so what if variance is large? That means numbers are spread out a lot. There are minimum is maybe 0.5 and maximum is 50,000. Then my variance will be very large number. Suppose my minimum is 2 and minimum is 2 here and maximum is 12. Numbers are not that spread around, so I'm getting 69.20. But suppose my minimum is 2 and maximum is 200. My variance value will be very high. So if variance value is very high, means numbers are spread across. There is a lot difference between minimum and maximum. And standard deviation also tells the same thing. If standard deviation is high, spread of numbers will be high. The difference between maximum and minimum will be high. Now I told you one more. Why? Suppose standard deviation and variance both are telling same thing. Spread of number, they're telling same thing. Spread of the number. Then why I need both standard deviation as well as why I need two measures, standard deviation as well as variance. I can take either variance or I can take standard deviation. Why I need two separate things? I told you answer for that. Anybody remember? Guys, anybody remembers why two are needed? You can take anyone. You take either standard deviation or you take either variance. Why you need two? I always calculate two. Variance also I calculate, and I calculate standard deviation also. Why I need two, guys? Tell me. Okay, so I will tell you the reason if you have forgotten. Suppose these 5 numbers 2, 7, 3, 12, and 9, they represent kg. Weight. You are doing some weight. Suppose weight of a maybe weight of a what kind of things you have this kind of weight. Suppose weight of a chicken, a very small chicken weighing 2 kgs. Chicken will never weigh 2 kg. Okay, for example, let us say not chicken, then take bigger ducks. So small duck will weigh, duck मतलब बतख होता है ना, बतख. Small duck will weigh 2 kg. A very big duck will weigh 12 kg. Just an example, okay, it is very funny example. But I'm telling, suppose it represents some weight. So if I do variance, so will it be, the unit of variance will be kg or kg square?
kg square.
kg square, right? Now I'm telling you one thing that I'm asking you, Jignesh only. Jignesh, what is the spread of these numbers in kgs? So you will tell, Jignesh will tell me 13.84 kg square. Is it making any meaning?
No.
My numbers are in kg, but you are telling me variance is in 13.84 kg square. Does it having any meaning? Does it have any meaning? But when I take square root of kg square, it will become kg, right? So when I take a square root of 13.84 kg square, it becomes 3.72 kg. Now I am telling Jignesh is like, I asked Jignesh, what is the spread of 2731219? Then Jignesh will reply, standard deviation is 3.72 kg. That is what standard deviation. Is it not making more sense, guys, compared to kg square? Guys.
Yes, sir.
So if my numbers are in kg, my numbers are in kg, my spread also should be measured in kg because it is a kind of difference only, na? So it also should be measured in kg logically. So how can you tell me it in terms of kg square? That's why I have devised one more unit called standard deviation, whose unit also is same as the numbers. If number unit is kg, the standard deviation also unit will be kg. If standard number is meters, standard deviation also will have unit meters on. That's why I have devised this. So that's why if you want to tell the measure to like spread to anybody, you should not give variance. You should standard deviation. So standard deviation is more common compared to using standard deviation is more common compared to your variance. Okay, and that's why we need to first we will calculate variance, but it is having square, so we go for square root. So standard deviation is more common expressing spread of numbers. You want to express, so better expresses in terms of standard deviation. So that's why we need these two kind of measures. Okay, so now what I will do, guys, is this I will share with you in the PPT itself. So that when I share this PPT with
Sir, one foolish question.
you, yeah,
If you just go back to that example, sir.
yeah.
Sir, when we do the 2 minus 6.6, it will not be in the minus.
But minus ka jab when you will do square of minus, it will be positive only, na?
Acha, okay.
Square इसीलिए तो कर रहे हैं. That's
Yes,
why we are
yes,
doing
yes.
square.
Yes,
That
yes.
we don't want to deal with sign.
Okay.
Whatever negative, positive you do square, it will be positive only, right?
Yes, sir. Yes.
That's why. So now, so guy, I'm
Yeah, so one more question.
one,
So, hello.
yeah, hello.
Yeah, one more question. So you're saying we definitely need a standard deviation, right? Because of the same unit. So then in that case, do we really need variance then?
No, but to calculate standard deviation, you have to go through variance route only. No? First, you
I
calculate
can
variance.
I can directly take the square root, no, in the formula.
Then if you have the value of standard deviation, you don't need to tell variance.
Okay.
If you just tell I have standard deviation of 3.7, nobody will ask you variance. Because even if he needs it, it is very easy. He can just put in calculator and square it. He can get himself. So if you are expressing standard deviation, there is no need to tell variance.
Okay.
Okay, no need to tell variance. Just tell only standard deviation. In fact, variance is not required. But variance to calculate standard deviation, the route is through variance only. No? I have to first go through variance. So in variance and then, but I am expressing standard deviation, no need to tell any variance. Okay, guys. So I am giving you here numerical example link. Got it, guys? Guys.
Yes, yes, sir.
Yes, sir.
That I am giving here. Here. No. Giving here. On variance and standard deviation. Okay, guys. So now you have this link. You can go through it once again. So now minimum, maximum values I need not explain. It is very straightforward. Now two concepts are there: kurtosis and skewness. So this will be very heavy for tonight because already I've been tolerating me for more than 1 hour now. So kurtosis and variance will take next step. But these are going to be very interesting concepts and they are new concepts. Okay. So might be possible that your engineering or you never learned out of them. So it will be very interesting to learn what is kurtosis. What is kurtosis was a like it is name of a scientist actually, German scientist maybe. I think German scientist. So based on his name and skewness. So these are two new measures we'll take up in the new class. Okay, guys. So with this, I end my lecture and I keep to open to questions. And I want to tell you what next class. So next class will discuss about predictive. We'll discuss about prescriptive. All these statistics will complete. And these are hardcore concepts of data science. Okay, we are very much interested in them. Like what is descriptive, what is median mode, what is standard deviation, what is variance, what is kurtosis, what is skewness, and how to see predictive analytics, what are the measures of predictive, prescriptive. These are very hardcore data science, very fundamental data science concepts. So we have to be very alert, and they're very interesting actually. So today we completed, say, out of 6, there are more than 6. So 3 mean median mode we have completed. Then standard deviation, variance, and minimum. So 6 concepts we have completed today.